Hello students, welcome back to Kota Scholars. And today we'll see all the exceptions of periodic properties. Okay, so let's start with first, that is atomic radius. First of all, before knowing exceptions, you must know the general trend. So the general trend of atomic radius is that from left to right it decreases, while from top to bottom it increases. And the exception in this case is noble gases have maximum size in their period. Like for example, if you compare second period elements, from left to right, it must decrease. So neon must be minimum, but in reality, it is maximum. So you must know that a noble gas will have maximum atomic radius in their period. So how will you arrange them? Neon will be maximum, then comes lithium, then beryllium, and so on. Next very important exception is of 13 group, where you see that from top to bottom, it must increase. But in reality, size of aluminium is slightly more than gallium. Okay, they are approximately same. This word can also be used, but in reality, aluminium is slightly more than gallium. For iridium and thallium, the size of thallium is still bigger than iridium, but they are approximately same. Actually, the size increase which you are expecting will not be found over here. The size of thallium must be much bigger than iridium, but in reality, they are approximately same, but still thallium is bigger. 14 group here also, you're expecting the SN and PB must be bigger. In reality, it is bigger, but the increase is not that much. So their size are approximately same. Next, let's compare for the scandium titanium series. It initially it decreases, then it becomes equal and then starts increasing. Till iron it decreases, then for iron, copper, nickel size is approximately same, and for copper and zinc it starts increasing. Important note point is that scandium and titanium are bigger than zinc. The size of a zinc is bigger than vanadium. It is still smaller than scandium and titanium. Okay, let's understand about the 3D, 4D or 5D series. This scandium, titanium, vanadium, this series is known as 3D series. Yttrium, zirconium, niobium is known as 4D series. This lanthanum, hafnium is known as 5D series. Now, important thing is that after lanthanum, I have got this star. This star is because after lanthanum, the entry of F block starts. And due to entry of F block starts, many things varies. So this is known as lanthanide contraction. But one thing you must know that lanthanide contraction is only applied after lanthanum. Okay, it is not applied on lanthanum. So whatever exceptions you'll be learning because of lanthanide contraction, apply it only after lanthanum. So what happens, the size must increase from top to bottom, but in reality, size is approximately same for 4D and 5D series. So yes, zirconium and hafnium will have a similar size. If you want to compare scandium, yttrium and lanthanum, the size of lanthanum will be much bigger than yttrium and scandium. Here, the lanthanide contraction will not be applied. It would be only applied after lanthanum. Next exception is of cesium and francium. You expect that francium is bigger because it is at the lowest, but in reality, cesium is bigger than francium. Next, you have ionization energy. Its general trend is that from left to right, it increases, while from top to bottom, it decreases. First exception is of 13 group, very important. Maximum is for boron, then thallium, then gallium, then aluminium and iridium. Okay, next exception is for 14 group. Here, PB must have lower ionization energy. That's what you expect from general trend. But actually, in reality, PB has more ionization energy than Sn. So here, PB will have more ionization energy than Sn, and in the first exception, thallium will have much more ionization energy. It will be just smaller than boron. From gallium and aluminum, it is very high. For 13 group, for next exception is for second group and 13 group. Second group will always have more ionization energy than 13 group. Beryllium will be more ionization energy than boron. Same goes for magnesium and aluminium. 15 group must have more ionization energy than 16 group. Nitrogen will have more ionization energy than oxygen, and phosphorus will have more ionization energy than sulfur. Next exception will apply for lanthanide series. This is again 3D series, 4D series and 5D series. This lanthanide contraction will applied. Like for example, we apply lanthanide contraction after lanthanum. And we said that all these variation which occur because of lanthanide contraction will only be applied after lanthanum. It will not be applied on lanthanum. So here comes the another exception because of it, and that's of ionization energy. You must know that ionization energy of 5D series will be maximum. So if you compare titanium, zinc-chromium, hafnium, hafnium will have maximum ionization energy. But if you compare scandium, yttrium, lanthanum, top to bottom it might decrease. So scandium will have maximum ionization energy. So do remember all these exceptions in these series will apply after lanthanum. Next is of zinc and gallium. You expect from left to right it must increase, so gallium must have more ionization energy, but in reality zinc will have more ionization energy than gallium. Next is electron affinity. General trend is from left to right it increases, while from top to bottom it decreases. You must know that wherever you see 18 group element, its electron affinity will be minimum. Then comes the number of second group. Then comes the number of 15 group. Then you start applying the general trend that from left to right it increases. Another exception is of first group and 13 group. First group will have more electron affinity than 13 group. For example, if you compare lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So whenever you are asked to compare electron affinity, and if you see a 18 group element, just keep it at the lowest. Okay? You just have to keep it at the lowest. So neon will have the minimum electron affinity. Then after that, you have to keep a second group element. Second group element is beryllium. So you'll keep beryllium. Then after second group element, keep 15 group element. That is of nitrogen. Then start applying the general trend that from left to right it increases. So now we are left with lithium and boron. But again an exception. As I told you, first group elements will have more ionization energy than first group element will have more electron affinity than 13 group. So here again an exception. Boron will have less electron affinity, while lithium will have more. Okay. Now you can start applying the general trend. We have already covered lithium, carbon, then you have oxygen, and then you have fluorine. Okay. So whenever you are asked to compare the electron affinity, just remember 18 group element will come at the lowest, then the 15 group, then second group, and another exception is of first group will have more ionization. First group will have more electron affinity than 13 group elements. Okay, then you start applying the general trend. Next exception is of third period and second period. As we know, by general trend, top to bottom, electron affinity must decrease. So second period must have more electron affinity than third period. But in reality, third period will have more electron affinity. And that's why phosphorus will have more electron affinity than nitrogen. Sulfur will have more electron affinity than oxygen. And chlorine will have more electron affinity than fluorine. And actually, chlorine will have maximum electron affinity in whole periodic table. Okay, so the maximum electron affinity will be of chlorine. Then comes fluorine. Okay, fluorine number is just after chlorine. The very important exception of next, that is oxygen, sulfur, and selenium. We know that third period element will have more electron affinity than second period. So it was expected the sulfur will have more electron affinity than oxygen. But in actually the new thing is that oxygen will have even less electron affinity than selenium. That is of fourth period elements. So here we have completed the exception of atomic radius, ionization energy, and electron affinity. Do revise it. Just remember them. Just remember the general trend and the exceptions and do the questions. I hope this video was helpful for you all. If you liked it, please like the video and keep learning and keep enjoying. Thank you, everyone.